Well, hello everybody. Welcome back. We are on learning target number 3 for the page 2 now. And so we were looking at this, and they want to find the value of x when A is parallel to B. That's what those vertical lines mean, and explain. So I'm going to start with my explanation. I noticed that the 65 and the 4x minus 3 are in the same relative position. So these are corresponding angles. And therefore, corresponding angles are congruent, would be part of my explanation that I would be explaining. And so now if I'm going to solve this, since they are congruent, 4x minus 3 needs to equal 65. So algebraically, I'm going to add 3. That gets me that 4x is equal to 68. And then if I divide by 4, I should get that x is 17. Now, if I put 17 back into this angle up here, I should get the 65, the same 65 that I got before. But the reason that x is 17 is that we use corresponding angles to set them equal to each other. Now, in the second example down here, these angles are no longer corresponding, but I do notice that they are on the same side of the transversal. Now, up here, corresponding angles are on the same side as the transversal as well. But the difference is that these guys are on the interior and they're same side. Their interior of the parallel lines are on the inside of the parallel lines. So these two angles are same side interiors, which means they are not the same angle, but they add up to be 180. So these guys are same side interior angles. And they are supplementary. All right, so since they're supplementary, that means they add up to be 180. So x plus 75 plus x plus 125 will equal 180. And so then when I start solving this, combining like terms, there are 2 x's and 200 on this side equaling 180. I will subtract 200. And I get that 2x is negative 20, and then I divide by 2, and that makes x equal negative 10. And I got that x was negative 10 because they are same side interiors, but we should probably just check because this seems kind of like a weird number to get. So if I put in negative 10 in here, that would mean that this angle right here would be 65 degrees. And if I put in negative 10 here, this would be 115. And I believe if I take 65 plus 115, that should get me 180. So therefore, that does work out for us. It's just a little weird. We haven't seen anything like that before. All right, and then finally, they want me to calculate the length of this segment. And there are 2 ways you can go about it. We have the distance formula, which we used a lot. That's where we took the x values and subtracted them from each other. And we'll start with that one and squaring them and adding together and all that stuff. So down here, we'll make this guy, let's call this one x1, y1. And this one will be my x and y. And so the ordered pairs that I'm going to use, this ordered pair is 1, negative 2. And this ordered pair looks like it is negative 5 and 5. All right, so those are my values that I'm going to use. And when I substitute them into my distance formula, I'm going to say 1 minus 5, 1 minus negative 5. That was negative 5, it's back 5. Minus negative 5, so it looks like that. And then the next one is, I start with negative 2, and I'm going to subtract away 5, because that's the y values. And so then continuing on with my distance formula here, I get to clean up the inside. And cleaning up the inside, 1 plus 5 is 6, so I'm going to square 6. And then these guys are subtracting. They're both negative, so they combine to make more negative, so I get stuff that looks like that. And then finally, if I square them, I will get 36 plus 49. And the final answer then will come out to be that the distance is the square root of 85, and I'm okay with that as its distance. The other way I could have gone about this is I could have gotten rid of the subtraction and I could have used Pythagorean theorem. And so I am going to, if I counted this way and then I counted vertically, I could get rid of the distance formula portion of this, and basically what would have happened is that I would have said, okay, this is 1, 2, 3, 4, 5, 6. That distance is 6. And this distance is 1, 2, 3, 4, 5, 6, 7. So I have those two side lengths. So then and this side would be my hypotenuse in my Pythagorean theorem, which would give me 7 squared plus 6 squared will equal c squared, which is 49 plus 36 equals c squared. And so 85 equals c squared, so the square root of 85 is c, which is the same thing. We got basically the same stuff in each one of these guys as we went from once we did the subtraction. So it's just the Pythagorean theorem might save you some steps if you've got a graph, or you could use the distance formula. Either way, that'll work. But this concludes our video for page 2.